Welcome to The Explainer. You ever wonder how millions of people can stream the season finale of a huge show at the exact same second and the whole internet doesn't just break? Well, today we're going to pull back the curtain on the invisible engine that makes it all possible. I mean, think about it. Everything online is designed to be instantaneous. You expect movies to just start, websites to load in a flash, and your games to connect without any lag at all. Speed is the name of the game. And yet, we've all been there, right? Staring at that dreaded spinning wheel, waiting for a video to buffer, or even worse, having a website totally crash on you. If everything's supposed to be so fast, what's the deal?
Now, it's easy to blame your Wi-Fi, but the real culprit here is actually much bigger. It's not a software bug, it's a problem of pure physics. We're talking about the sheer physical distance that information has to travel.
You see, every single time you click on something, you're sending a request to a server that could be thousands of miles away. That signal has to zip through undersea cables and bounce between data centers just to get to you. That travel time, that delay, that's what engineers call latency. For you and me, a little bit of latency is, just annoying. But for big companies, it's a complete disaster. We're talking about milliseconds of delay costing an e-commerce giant millions in sales, or causing people to cancel their streaming subscriptions in frustration. The stakes are just unbelievably high.
So, if we can't actually make data travel faster than the speed of light, and trust me, we can't, how did the internet get so incredibly fast? How did we solve this fundamental problem of distance?
Well, the answer is this absolutely brilliant piece of engineering called a Content Delivery Network, or CDN. At its core, it's a worldwide network of servers with one simple mission: to shrink the distance between you and the stuff you want online.
The best way to think about it is like this. Instead of everyone in the world ordering from one giant warehouse in, say, California, a CDN sets up thousands of local data warehouses all over the globe. So when you want to watch a video, it doesn't have to travel halfway across the world. It just comes from the local shop right in your neighborhood.
But here's the thing. A CDN is so much more than just a storage system. It uses a few really clever tricks. We're talking caching, load balancing, and smart routing to build an internet that's not just faster, but way more reliable for all of us. It's actually a pretty elegant process. When you click play in a video, your request doesn't go all the way to the original server. Instead, the CDN grabs that request and sends you to the closest server, the edge server, that has a copy, cached, or saved. If for some reason that local server doesn't have it, no problem. It just quickly grabs it from the source, saves a copy for the next person who asks, and then sends it right over to you.
And what's really powerful is that the big services out there, they don't just rely on one CDN, oh no. They use a whole cluster of different providers, all working together. This means if one CDN has a problem in your area, your traffic just gets instantly rerouted to another one. It creates this incredible safety net, so there's no single point of failure.
CDNs also act as the internet's traffic cops. When a massive new game drops and millions of people try to log on at the same time. A CDN uses something called load balancing to spread all that traffic out across its entire network. It makes sure no single server gets overwhelmed and crashes under the pressure. Okay, so this isn't some abstract theory. This is the real-world, operational backbone of the modern internet. To put it bluntly, the biggest names in tech just couldn't exist without it.
Just look at Netflix. They got so big that they built their own custom CDN, and it cut buffering in half during big show releases. Amazon uses a super complex CDN strategy to handle the insane traffic during events like Prime Day. And gaming companies like EA, they absolutely depend on CDNs to cut down that lag so millions of players can all compete in real time, all across the globe.
But this technology is not standing still, not by a long shot. CDNs are evolving. They're going from being simple delivery pipes to being these intelligent, predictive engines that live right at the edge of the network, closer to us than ever before.
I mean, the pace of change here has been just incredible. What started in the 90s as a simple way to fight latency, it quickly had to evolve to handle the explosion of video streaming. And now? Now we're seeing the integration of seriously cutting-edge tech, like edge computing, AI, 5G, and even little bits of code that run directly on the network itself.
And that brings us to this huge trend called edge computing. The big idea here is that instead of just storing stuff closer to you, the network can actually start to process information on those local edge servers. This is a massive shift. In fact, by 2025, it's predicted that the vast majority of enterprise data will be processed right there at the edge, not in some distant centralized cloud. And this is where things get really, really futuristic. By using AI to analyze all our traffic patterns and behaviors, CDNs are starting to predict what you're going to click on next. They can then preload that content onto the server nearest you before you even ask for it. The goal is to make the internet feel completely, truly instantaneous.
So that brings us to one last really big question. This invisible technology, it started out as just a simple tool to make things faster. But as it gets smarter, as it starts predicting what we want before we even know we want it, is it still just serving our demands, or is it starting to shape them?